Hi, welcome to Project Geospatial. I'm Adam Simmons here at the GEOINT 2022 conference in Denver, Colorado. I have the pleasure of being at the Phase 1 booth talking with Dana Brown. Dana, you mind introducing yourself in terms of who you are, what you do, how you got in the industry before we touch on the company?
Sure. My name's Dana Brown. I work with Phase 1. I've been on board for about 6 years. My previous career was with survey and software professional equipment. There was a need for bringing this type of technology to mapping and survey customers. And so that's what brought me here to Phase 1.
Okay, well, I guess that's a great segue into Phase 1 because I want to know what kind of technology you're working on transitioning, right?
Excellent. So from Phase 1 perspective?
Well, you mentioned transitioning technology into, that's how you got into this, right?
Yeah, so previously I was working with mobile mapping systems that had LiDAR and camera equipment. And some of the challenges when you're taking images is being able to see a lot in a single view. Low resolution cameras do not deliver that for you. And so the Phase 1 camera was that nice transition because it gives you a wider field of view. Except for my background was terrestrial from the ground, not from the air. And what Phase 1 offered at the time was aerial type solutions. But they had a need for someone to talk to mapping customers, engineering firms, and survey firms about what that could do. And that's what brought me on board.
Excellent. So let's talk about the company. You touched on cameras.
Yeah.
What overcompassingly is Phase 1 all about?
So Phase 1 started in the early 90s as a camera company.
Okay.
Right? And it was for professional photographers, for fashion photographers, landscape photographers. But about 10 years ago, there was a company that said, we'd like to take a Phase 1 camera and put it up in the air and take pictures from it. Well, that required a few changes. So instead of just having a camera for professional photographers, then we redesigned the camera that was more industrialized. And it looked more like the older generations look more similar to this.
Okay. Tell us what we got here.
So this is the camera, the integrated part itself with the sensor chip and all electronics. And then you have the optics here. So you'll see it's about a very industrialized housing on it. And also the lenses are also industrialized and they're set to a fixed focus as well. That's important in mapping to not have to change the focus because then you lose the quality of the metrics of the images on the mapping site. So that's what's important.
What are we talking about for specs on this thing?
So this particular camera is 120 megapixels.
Ooh.
Yeah. Now, this isn't really our mapping camera. This is the reason why we're here at this show today.
Okay.
But I'll segue to this in a minute. This is kind of showing the examples of the camera. So this camera then was integrated into pods for airplanes to do mapping.
Okay.
We grew from having just a camera that went into some pod with other third-party products to building our own turnkey system. And that's what we have over here.
Perfect.
We'll start with the big one first, okay?
Okay.
This here is an 880 megapixel camera system. It's got 4 oblique cameras at 150 megapixels apiece and one 280 megapixel nadir. And the combination of that grid gives you the ability to create 3D city mapping. It's a big demand for today to do digital twinning.
So with these cameras up in the air, what altitude is most preferred to get the most out of the resolution that you have?
Well, see, that's the nice thing about our cameras. So every client and every end user of the data typically wants some kind of a different deliverable. So you fly at different altitudes, 2,500 feet, 5,000 feet, 7,500 feet. But the best resolution you get is around 2,500 to 3,000 feet with 2.5 centimeter GSD. So less than an inch GSD with this system.
That's incredible.
Yeah. The other key thing about these systems and the cameras is that it has a high dynamic range. What does that mean? What it means is when you're mapping and you have a lot of shadows and you want to see the details in those shadows, with the high dynamic range that comes with Phase 1, because it's a medium format chip in there, it allows the ability to see in dark shadows for mapping and even for intelligence gathering.
So taking the HDR on your phone to a whole new level, right?
Absolutely. So this is the big one, right? The one that covers a 3D city for mapping. But there's also the companies that want to put a smaller system in a smaller plane. This is a single camera system. It still has the stabilized mount. Still comes with the GNSS IMU. Okay. Which then allows it to create images that are very flat because it has a stabilized mount. This is a 150 megapixel camera. So just think about.
So this helps adjusting as vehicles moving. correct? Is that what
Yeah,
you mean by
that is
stabilization?
correct. Yep.
Yeah.
As the plane's moving, if it's crabbing or if it's dipping.
As
right?
a photographer, I'm used to dealing with that, putting a camera on a star tracker, doing nighttime photography.
Yeah.
Something similar to
Yeah,
that.
excellent. This keeps it flat, so it's looking straight down. For
Excellent.
Sure. Yeah. So you have this one. So these cameras fire at about 1 to 2 frames per second. In the mapping world, that is more than sufficient when you're flying at 150 knots or 100 knots. Okay.
Excellent.
In the world for geospatial intelligence or geointelligence, we can't fly that slow and we can't capture that slow. We need a faster frame rate and we need to be able to capture at a faster speed. So that's where the camera comes into play. This particular camera is the 120 megapixel cameras we mentioned before, shoots at 7 to 12 frames per second. And that's of very big importance when I'm trying to do some type of surveillance over a city or an area of interest, to not be there too long, right? I don't want to be a target. And so with this camera, it gives you that ability to do that. And it gives you a wide area field of view. Think about like a 2 square mile radius that you're capturing in a single frame. The type of pods that are in place today with the low resolution cameras have more of a soda straw effect, which is great. The soda straw, I can see the details, but the context awareness, I don't see. The situational awareness, I don't know. With the camera like this, I have the ability to do so. Now, with a 120 megapixel image comes a lot of bandwidth and data that's required.
Well, that was my next question. With 120 megapixels, even some of these other ones,
yeah.
How big is a single image in terms of storage?
Right. So because we use a RAW format, it's 120 megabytes per image.
Okay.
But still, when you're in a mapping mode, that's okay, because at the end of the day, I'm going to land the plane, I'm going to pull the hard drives off, I'm going to process the data, create my map, right? But in this type of scenario, when I need intelligence information immediately, I have to be able to process that on board. So we rely on third-party computer processing then to take that image and process it. One of the unique differentiators of the chip in here is that it supports multiple regions of interest. So multiple regions of interest means instead of taking a full frame, taking that 120 megabytes, processing, getting the information, I can designate specific areas on that, right, and just get those areas of interest to do change detection or any type of analytics to that.
So you're even helping with the processing as you go.
By giving the tools for the processing to do that.
Excellent.
Yeah. So that's really the value of this, and that's where we see this going. Now, we're at the GEOINT conference, which also involves space customers. They want to put cameras in space, right? Phase 1 has now taken that next step, and we're working with companies that take these variant cameras, create them, make them space hardened so they can operate in LEO orbit. So 120, 150 megapixel imagery from 500 kilometers in the sky.
Excellent.
Yeah.
Awesome. Well, all right. Well, I'm a little overwhelmed. You told us about 3 different amazing cameras here. So thinking a little bit for a second, is there anything else about Phase 1 you'd like to share to either your potential customers or even young and aspiring youth about the industry?
Well, sure. I mean, technology is always changing, so invest in knowing about geospatial intelligence and geospatial products, because mapping the world is important. Having intelligence to know what is and where it is and how to mitigate issues and concerns is of extreme value. So go down that path. You know, I started when I was a kid drawing maps with a pencil and paper. You know, that was my inspiration to being a geospatial professional that I am today. So don't squash that passion if you have it.
Once again, thank you very much. Dana, your technology, your camera technologies is absolutely incredible, and I can't wait to share that with all of you at Project Geospatial. We will talk to you next time.
Awesome. Thank you, Adam.
Thank you very much.